Hello, friends. Thank you for joining me. Happy New Year to you. Thank you for joining me once again. Thank God that you made it to this year 2025. And thank you for joining me on TJ's Maths Clinic. TJ's Maths Clinic before, it was called TJ's Maths and Further Maths Adventures. So it has been changed to TJ's Maths Clinic. The word clinic there is this channel should be a place whereby students will go when they have issues in mathematics, further mathematics, and physics. It's not necessary that somebody must have issue before the person can visit a clinic. No. You may go to clinic for consultation and for checkup. So that is why the name TJ's Maths Clinic come into be. So subscribe to TJ's Maths Clinic. Let's look at this further mathematics objective test 1 GCE 2024. With us here is question 28, 29, and 30. In my previous video, I have solved question 1 to 27. Let's look at how we can handle this question before us. Once again, Happy New Year. The question reads, find the bearing of the resultant of the vectors P, which is given as 5i plus j, comma, vector Q, which is I minus 2j, and R is equals, that's vector R is equals to 3i plus 16j. This is the resultant. We're asked to find the resultant of vector. This is from vectors. Find the bearing. We'll see use the knowledge of bearing as well as vectors and the resultant, how we can find the resultant of a force. You know, vector is a force is a vector rather, because force has both magnitude and direction. So let's look at how we can handle this. Let's write down the solution here. That's solution to 28 now. The resultant now are, we sum all the forces, which is given as P plus Q plus R. This will be the resultant. So we add P, we have 5i plus j plus I minus 2j plus 3i plus 16j. So it means we have to add I to I, j to j. Very important. So you will say 5i, or we can remove the bracket first. Yes, let's remove the bracket first. But since we are adding, we can say 5i plus I, that's 6i plus 3i. That will be 9i. The resultant now will be 9i plus or minus. Let's see. Let's go to j now. It will be j minus 2j. That will be minus j. Minus j plus 16j. That will be plus 15j. So this will be the resultant. But we are asked to find the bearing. To find the bearing, now the first thing for us to do is to represent this information on the Cartesian plane. And if we are to represent this, we'll have the x-axis and the y-axis. This x-axis is associated with I, and this is our j. So 9i, it means we move 9 steps or 9 units to the right horizontally. So here will be 9, for instance. Then 15 plus 15j means we move 15 units up, horizontal, up now vertically. So here will be 15. Then we have the angle of inclination here. This is 90 degrees. Then let's say this angle is alpha. Then this is the bearing we are looking for, because we have to start from the north pole. This is our north pole. Very important. So to do that, let's find alpha first. Let's find alpha. This is opposite adjacent. So we use tan alpha now will be opposite, which is 15 divided by 9. Alpha now will be the tan inverse of 15 divided by 9. What will be tan inverse of 15 divided by 9? Let's use our calculator. Ensure that your calculator is in degree. Very important. Then press shift. Then tan inverse of 15 divided by 9. What do we have? We have 59.03 degree. 59.03 degree. But that's not what we're looking for. So we know this angle now as 59.03 degree. But we're looking for this other angle here. on our Cartesian plane or on our cardinal point, from this north pole to this east here is 90 degrees. So to find this bearing, now we are asked to find the bearing of the resultant. This is the resultant here. This is the resultant here. The bearing of the resultant now will be 90 degree minus this alpha here, which is 59.03 degree. What do we have? Minus, remove this from 90 now, we'll have 30.96 degree. Approximately it will be 31 degree. So the bearing of the resultant is nothing but 31 degree, and the correct option is option A. Care must be taken, please. Here option B is 059 degrees. So they can put this as the answer there, but this is not the correct answer. The correct answer is 31 degree, which is option A. Very important. Let's move to question 29. Let's move to question 29 and see what we'll get. Okay, let me clean here. Permit me to clean here so that we can move to question 29 and even here too as well. Let me clean here. Permit me to clean here. Let me carry the better this thing, okay? So that we can clean here very well. Let's move to question 29. Question 29. Let's write solution to 29 now. Solution to 29. Question 29 reads, find the sum of infinity of geometric series. This is a geometric series. This is under sequence and series. So we are asked to find the sum to infinity. Sum to infinity of geometric progression or geometric series is given as sum to infinity, which is equals to A divided by 1 minus R, where A is the first term, R is the common ratio. Very important. Then here, let's get our A. Our A is 2 divided by 3. The common ratio now will be, this is our first term, this is second term. It's going to be T2 divided by T3, T1, or T3 divided by T2 under geometric progression or geometric series. So T2 is 2 divided by 9 divided by the first term, which is 2 divided by 3. This is the same as 2. This implies this will be 2 divided by 9 times 3 divided by 2. If we check this division to multiplication, we have to invert 2 and 3. Meaning 3 will move to the numerator, then 2 will come to the denominator. 2 here, 1, 2 here, 1, 2 here, 1, 2 here, 3, and 3 here, 3. We have 1 over 3. So our common ratio is 1 over 3. First term is 2 over 3. Let's substitute. Sum to infinity now will be equals to A, which is 2 divided by 3, then 1 minus 1 over 3. Let's work on our denominator. This is over 1. Let's find the LCM. The LCM of 3 and 1 is 3. 1 into 3 is 3 times 1, 3. Minus 1 into 3 is 3 into 3 is 1 times 1. That is 1. So this will be 2 divided by 3. So this is what we have in the denominator. Sum to infinity now will now be equals to 2 divided by 3. That's our numerator now. Then divided by what we have in the denominator, which is 2 divided by 3. This implies that 2 divided by 3, we change this to multiplication. That will be 3 divided by 2. 3 here, 1, 3 here, 1, 2 here, 1, 2 here, 1. At the end of the day, we'll have 1. So the correct answer is 1, which is option B. So that's the solution to 29. The last question, but not the least, is question 30. Let's look at how we can solve 30, and that will be the last question for this presentation. Question 30, we are asked to write the expansion for the fourth term of the binomial expansion of this under binomial theorem. Very important. Let's look at it. We are asked to find the fourth term. When we expand this binomial expansion, n, which is 10, has to be, n must be one more than n more. That's one more. When we expand this, we are expected to have 11th terms. So it means in any binomial expansion, the expansion has to be one more than the given time, which is n. So when we expand this, we're expected to get n plus 1. In every binomial expansion, we must have n plus 1. Okay, so, but we don't need that. We're asked to find the fourth term, so we use the general formula. The general terms in binomial expansion is given as t r plus 1, which is equals to n combination r, a power n minus r, then b power r. This is the general term in any binomial expansion. So, r plus 1, we are looking for the fourth term. What can we add to 1 to give us 4? Of course, it will be 3. So, r is 3. N is what? Our n here is 10. Then the first term, which is our a now, here is 1. Then b, which is the second term, is x divided by 2. So it's just a question of substitution. Let's substitute. So t4 now will be 10 combination 3, which is our r now, times 1 power 10 minus 2 into x divided by 2 power r, which is 3. Very important. Let's simplify. Let's use our calculator. We have 10 combination 3. What do we have? 120. So this will be 120 times 10 minus 2 is 8. 1 power 8 is still 1 times x power 3. That will be x power 3 divided by 2 power 3 is 8. Very important. Here we can say 8 here 1. 8 into 120. 120 divided by 8, that's 15. We have 15 here. Finally, the fourth term will be equals to 15 times x cubed. That will be 15x cubed. And the correct option here is option A. So this is the solution to question 30. Thank you for watching. Please do share this to your learned colleagues. In my next video, we'll continue from 31, God's willing, down the line. Thank you for watching. Please do share this to your learned colleagues. And don't forget to subscribe to TJ's Maths Clinic. You can follow me on TikTok, Instagram, and Facebook. See you in my next video. Once again, Happy New Year.